Today we are going to install the Image 2 panel utilizing our residential flashings. These flashings are designed with open hems, bends, and tabs for simple installation. The overall flashing size has been tailored to complement the residential look. The installation details minimize the need for exposed fasteners. To prepare the substrate for the new metal roof, you'll need to remove any existing shingles or other roofing materials and replace any deteriorated wood. It is important that the substrate is level and in plane before the new metal roof is installed. This will give the homeowner the best looking finished product. What we don't want to do is just come to a roof area, start with the panel on one side and move across the roof. Issues that can come up or arise when doing so include, as you come across, if we start with a 16-inch panel and just work toward the hip and then tie in the hips together at the same, make sure that the ribs line up. As we get over here across to this penetration, we could end up with an issue, whether it be that the rib is close to the penetration, cutting off the flow of water, or that we're just out of symmetry as we come across the roof. So with this particular roof, what I'm going to want to do, what is important here is this penetration. That's going to be the main issue on this roof. So we're running a 16-inch Image 2 panel. This penetration measures 11 inches wide. So what I'm going to want to do is I'll want to put a rib right in the center of this penetration. By doing so, if I put the rib in the center, 10 inches, so we come out to 5 here, we can start with 13-inch panel. Have a 13-inch panel, move to a 16, measure to our valley, that's another 13. I'll come out of the valley with the same number, 13, 16-inch panel here, and then my panel coming into the hip is an 8-inch panel. Again, I transfer that 8 inches around to the other side of the hip, 16-inch panel, 16-inch panel, and I'll end up with a 2 or 3-inch panel on the other side. Normally a 2-inch panel would be a concern. However, this is up against a rake wall. It's not going to be an issue. What is an issue is this penetration, so we just need to make sure that we have proper water flow around this penetration. Next thing we're going to talk about is the underlayment. What you want to have with the metal roof is a high temperature underlayment rated for 250 degrees or more. MSHT is Metal Seal's high temperature, our product. What I personally really like about this product is it has the white backer, the Tiger Paw anti-skid backer, but it's white and it's not going to hold the heat in the summertime. A lot of times what you'll get with an ice and water shield, you'll put it up on a 612, something that's hard to walk, and you'll feel your body just slide down the roof as the tar melts under your feet. This is a great product. What's very important with this, we want to make sure we're all the way out to the eave with the underlayment as we start off. We'll do a peel and stick or an MSHT type of underlayment along the eaves and then the valleys. There is a specific sequence that you go through in installation. First we install along the whole eave all the way around, and then we're going to put the valleys in, a strip right up the valley, and then whether we're running MSHT or another type of underlayment, then we'll fill in the area of the roof over top. It's important that valley goes in first. So we have our underlayment on, our substrate's in good shape, our fascia's in good shape, and we know what kind of layout we're going to do. The next step will be to put our Eave flashing on. Now there are two types of Eave flashing. There's extended Eave, which is what I'm going to use, and the standard Eave. This is a 1.5-inch extended Eave. This Eave flashing, it's important that it fits the roof correctly, that it's at the correct angle. You can see that this extended Eave hangs over 1 inch. So in measuring this roof, when I'm measuring for panels, I'll just pick any random place on this roof right here, I'll mark it, and I'm going to measure from the point where these two planes cross, here to here, it's 29.5 inches. If this is a standard Eave, which is basically going to, the metal is just going to be on like this with an offset cleat in here. What I'll have 29.5 inches, and I will add 1 extra inch for the hem. We're going to hem all these panels on this image project here. So what I'm going to, if I want that panel to end up here, I'm going to have a 30.5 inch panel. If I'm using this extended Eave flashing, I have to add 2.5 inches. So I measured to this point, put my extended Eave flashing on. I'll have to add this 1.5 inch here and the 1 inch return. So if I have a panel measurement of 29.5 inches, I'll add 2.5 inches and order a finished panel that is 32 inches long. 26 inches, plus I'll have a tab. I'll have a tab on the inside and then a tab on the outside. So 28.5 inches is what I'm going to measure and cut this panel, or this flashing. I recommend using a combination square for many reasons. You'll see me using this blade for hemming panels. Also, this slides easily, and it helps you cut in cutting miters on metal. So I'll come out to my mark. I'll add 1 inch. Put my 1 inch tab here. With this side, this hem, this drip edge, I always want my points to miter together, to come together, so that the drip edge, or my rake edge that does have the same drip edge, I want this point to meet this point coming out. So what I'm going to do is I'm going to cut a 45-degree angle in that drip, and then I'll just cut my notches out here. At this point, to turn this tab, I'll use a pair of hand folders. I'm just going to put it right on that hem, right on my line, and turn it over to a 90-degree angle. On this side, since this is an inside miter, I'm going to cut my 45-degree angle to the inside here. Cut this tab. So I will go from my straight line I'll make a small cut in here. Again, take my hand folds right on the line, turn it into a 90. So it's always important on any of your flashings, you always want to leave tabs. Tabs are going to allow you to connect these with rivets or any other type of fastener that you may be installing. So that would be it, that would be finished there. What's important when this is installed is that this stays at a 90-degree angle, that it is the same angle as the fascia, and that you have enough metal coming up here to secure into the substrate. I have these pieces cut. I'm going to install them as we work around. We've got the outside miter, inside miter. Again, I'm going to do the finish on the inside miter. On my finish cut, there are no tabs. It's just a straight cut. And when these are installed together, they'll slide right up into each other. It'll close off that miter for me. Make sure that's in all the way. I'll check my angle here, make sure that's correct. Install screw. I purposely cut this last section into 2 pieces. I've cut this piece of Eave flashing again with the 1-inch tab. Always, again, as I said, important to add a 1-inch tab whenever you may have another piece of flashing as a connector. I've got the 2-inch telescope notches in this piece of flashing. Place it on the roof. Again, it's very important that the angles are correct. Screw in, snug up your screws. My next piece of flashing is then measured from that notch out to the end. And this is the finished cut. I already have the tab on this piece. So my cut here is a finished piece set at a 45-degree angle, 1 inch out on the miter. If this bottom tab is not open, I'll take a screwdriver and open that up. And then I'll slide these together. Again, minimum 12 inches on center on the screws. I recommend putting them closer together. Now I'll come back after the fact and put 1 rivet into this face so that I can make sure my miters are nice and tight together. Once I have my flashings connected, what I want to do is close this up as nicely as possible. Again, making sure that I'm connecting my miter points. I'm going to take a number 30 or 1/8 inch drill bit, and I'll go right through that 1 inch tab that I left. I'll take a pop rivet, install. It's important you have the pop rivet completely seated before you start squeezing, and also that it's flat. 2 squeezes, pop rivets in, nice closed miter. The drip edges come together nicely. The next section, once we get the Eave flashing on, is the valley. We're going to put the valley in next. We use a W valley. And what's important in this situation, because this is just a short roof mock-up, I know that this valley's nice and straight. In a lot of cases, though, you'll run into homes that have valleys that come up and have a jog one way or the other. In that case, what you want to do is you want to straighten it as much as possible by floating it off to one side or another. Even if it's not completely straight, that's okay, but we want to get it as straight as possible. So when I'm laying this valley flashing in, I'm going to want to go right through the top miter point in the substrate, slide it all the way up, and then I'm going to look from the bottom side, and I'm going to make sure this point is lined up with my miter in my Eave flashing. So in this case it is. Put pressure on here, and I'm going to take my pencil and I'm going to scribe the underneath side of this valley along the Eave flashing. I'll take this to the bench and I'll make my cuts. What's important now is to fold a hem on this flashing. Previous installations have just shown a raw cut here, but by leaving that raw cut, you can see the cut marks, and also you're not closing off that valley end. We want to completely close the ends of the panels, the valleys, all the flashings to make sure that we keep birds, bees, other types of insects out. So in this case, I've got my line that I've already transferred from the bottom of the Eave flashing. I'll take my square blade, again, which measures 1 inch wide, and I'll put a 1 inch line onto the metal. To make this easy, I'll put a B and a C. B stands for bend, C stands for cut. Do the same thing on the other side. I'll now take my straight snips and make my cuts on my cut lines. Come over to the other side, get it started, switch over to the top, make my cut. And then I'll finish it off with the aviations. Anytime you're going to be folding metal over, it's always a good idea to put a little notch there, and that'll help to get that fold started. Again, notch for the fold, and I'll notch back to the line. Now, I'm just going to use the hand folds in this case. If I had a flat surface, I may use a different type of folder, but in this case, I'll just use the hand folds. When using these, you want to give it support with your hand and just go little by little with the bend. If I do one large turnover, I'm just going to create large creases in this metal. So I'll go little by little, back and forth, and again, I'm using my fingers as a backer to help that metal fold its way over. To close my hem now, I'll use my square blade and a piece of cardboard. Place the square blade inside of the hem, put the cardboard over the top, and use my hand folds to squeeze it together. I don't want to use a lot of pressure. I just basically want to roll it right over. One side and the other. It's very important that anytime you close a hem on a valley flashing or I close a hem on a panel, that I do use cardboard. If I don't, what will happen is where this closes on the metal, on the face, you'll get a crease on each end of this pair of hand folds. And we don't want that to be seen after the metal's installed. So I've got my hems ready, I've got an opening, I'm going to now install it. To install this piece, just place it in the valley, and I'm going to lock my hems over the extended Eave edge. I'll know this is in place correctly when my two ends are closed and it pushes right up. I'll then check my angle, and it is at the proper angle. Once I have that in the proper place, I'm going to put 2 screws in the metal to hold it. And I want to put the screws right on the outside edge here. One on one side, one on the other. I'm now going to close this end off. This is a large W valley, and what I don't want, again, a bird could easily come up inside of this roof, bees, any type of insect, so I want to close that off. So what I'm going to do is I'll just pick a point at which I want to fold these tabs over. I can come across to where a 90-degree angle is. If I drive this all the way up and to the point, these points will connect right here at the top of that W valley. I'll take a pair of snips and I'll make a cut along the top all the way up to that mark. Now at this point, I'm just going to fold these together to a point. I want to now draw a line from this eave to this eave in the same plane. So I'll come for this corner, place a mark, come across to this point, place a mark, and just basically scribe a line. And then I'll add a 1-inch tab down below. Make this cut. And I'll take my hand folds and I will fold that under. I'll then bring the other side down and basically figure out where all these points, any place the point, the metal comes together, that's my point. That's what I'm going to use at a 1-inch tab and make that cut. And again, I could leave it looking like this. However, more professional appearance, you'll want a straight line right down through this valley. So I'll draw a straight line and I'll cut that right out. So that my finished appearance is a nice tight closed end. Again, keeping animals out and looks very aesthetically appealing. My next step, once I have my valley flashing installed, if this was an exposed fastened panel, at this point we'd cut our panels in and we'd install them into the valley. However, this is a concealed fastener system, and what we're going to put in on each side of the valley is an offset cleat. Offset cleat measures 1 inch, steps up, and then 1.5 out. And there's an offset so that when it sets down on a flat surface, it comes up so that there's a small space that you can attach the panel. So this offset cleat measures 3 inches wide. What I recommend is measuring from the inside part of the W valley and measuring out to a point 5 inches away. We want 5 inches of reveal here in the valley. The easiest way to do this is to take the 5 inches plus the 3 inches, which is a total of 8 inches. Place a mark on the valley, down low, up high, making sure that your tape or your measurement is 90 degrees off of the W valley, 8 inches. And then I'll just draw a line, connect those marks. It's very important that you measure not every 10 feet, but from the very bottom of the valley all the way to the top of the valley. As I mentioned before, you may have a valley which is not completely straight, and you may have to put a slight dog leg in that valley. That's fine for the valley flashing itself. However, this offset cleat must be in a consistently straight line from eave all the way to the high side. That'll allow each panel in the valley to have the same skew measurement on it. So once I have the lines on both sides, 8 inches out on the back side, I'm then going to take double bead butyl tape and attach it to the back side of my flashing. This is double bead butyl tape. It's easily seen. It has 2 beads. Double bead. It's much thicker than single bead. Thicker and wider also. Why it's important to use double bead butyl tape. Number one, you want a seal of this butyl between the 2 pieces of metal. In this case, the metal valley and the metal offset cleat. If we use a single bead butyl tape, the chances of there being no gaps in between the 2 pieces of metal would be very slim. Also, we want to put our fasteners directly through that butyl tape. Single bead is much too narrow to allow for that, so double bead is the way to go. So once I have my flashing cut, again my offset cleat, I know how it's going to be installed. I'm going to turn it over and I'm going to run butyl tape along the back side, along the attachment. All the way to the end, and then I'll just simply press it in. Make sure to peel the backer before you install. And again, back line or back edge is right on your line. I'll put one screw down low, press the metal up, put one screw at the very high side also. When installing screws in the offset cleat, space fasteners every 6 inches or closer if necessary. What is very important is that the butyl tape underneath the flashing is compressing the two flashings together so that any water that runs down the valley cannot back up and enter the roof system. At this point, once I have the Eave flashing in, the valley flashing, my offset cleats, I'm going to take double bead butyl tape and I'm going to put it along the top edge of my Eave flashing. That's going to prevent any water from backing up, whether it be an ice dam or any type of driven rain that could enter the ends of the panels. This will prevent it from going up the roof. So I'm going to place it right below the screws. All the way around the roof. That butyl tape creates a seal again from the elements. The next step in the process is to install the Rake cleat. If you look at this Rake cleat, you'll notice that it is different from the standard offering. Standard offering has a kick and a vertical. The new Rake cleat returns onto the roof. A few of the benefits of having this return onto the roof. Number one, it sets this Rake cleat perfectly at the right level every time. Issues that I know people have had and do have with the standard Rake cleat is if I'm on the roof and I mark the bottom of my rake flashing, having to lean down over and try to find that mark makes it difficult. This puts it in the perfect position every time. Another benefit to this Rake cleat is that if you're dealing with a rake edge that is not straight, if you have a little bow in your roof, which happens very frequently, what I can do is I can either by eye or I can chalk a line from down at the eave all the way to the high side, and if I have multiple pieces, I can pull them in or out off of that rake edge. That may make this face hang over top of the rake, however that is okay because I will be fastening it after the fact. So I'll secure on the top with a couple of screws, and then I'll add screws into the Rake cleat. I want to make sure they go in flush, that they're not at an angle, and I want to bring them down as close to the break as possible. That gives all the stability to that piece of metal. And a piece that short, I'm just going to add two screws into this piece. We'll have additional fasteners once we put the panel in place. When we cut our first panel in, when we did our layout, spoke about layout, we talked about placing the panel rib in the center of our penetration. When I put it in the center and I measure out, that is 12 1/4 inches. So I want to cut my panel down 12 1/4 inches and turn a 1-inch tab up on the edge to complete the rake flashing. The next step of the process is to notch and fold the panel. When I say fold, I mean turn a 1-inch tab on the bottom of this panel. I'll either be notching panels to go left to right or right to left, and that's how they are installed. Looking at the display, I'm going to be running panels left to right. So when I take this panel and turn it over, see the next panel here will be installed here. So I'm starting on left edge, and I'm moving to the right. So I know this is the correct edge that I want to put my hem onto. I'm going to fold 1 inch. I've got a 1 inch extended eave. Set that at 1 inch. And I'll place a mark at the end on the male edge and on the female edge. I'm going to be making a cut. To go for panels that are going left to right, I'll be using a pair of lefts. I'll first put the snip over the edge of the metal on the female. I'll look straight down and make a cut straight down to the bottom of the hem, or the bottom of the rib. Cut straight across and fold. Once I make that cut, you'll see that there are 2 breaks. 1 break here, 1 break here. I want to make my cut right in the center of that break. So again, snips, cut straight through. I'll now notch this panel down on the bottom. Slight telescope notch each way right back to the point. I'll take that tab and fold it in. I'll go over to the male edge, and here I want to telescope my notch back. Make my cut in, turn up, and again I don't want to cut straight down, I want to telescope it in slightly. Just pull that away. Now I'm going to use a hemming tool to turn the bottom of this panel. I'll take a 2x4, place it under the panel. That's going to give the metal stability. Slip the pocket over top of the tab. And I'm going to place all of the force right down on that edge. Give a nice crisp bend here. Now if I'm installing over an extended eave, I can install the panel as is. Hook it on, and I can come back later with the hand folds and pinch it tight. If I'm going on an eave flashing that has an offset cleat, I'll take my square blade, place it in that hem, and again take cardboard so that I do not distort the panel, and just roll the panel tight onto the square blade. I still have extra metal here, and I can either cut it in place right now or do that after installation. The panel ends with a closed end, so the panel's hemmed and a closure on the end cap. 12¼ inches plus 1 inch. It is plus 1 inch because 1 inch is the height of the rib, the panel rib. If this happened to be, for instance, a vertical seam panel, I would turn up a tab 1 3/4 inches because that is the height of the rib. In this case, it's 1 inch, so I'm measuring 12¼ plus 1 inch, 13¼ inches is what I'll measure on the panel. I'll take a straight edge, draw a line here, and now I'm simply getting rid of the hem and the extra metal that I will not be needing to make my cut through this panel easier. Once I have that panel cut, again, this is 13¼ inches, I'm going to turn up my 1-inch tab. The easiest method to turn up this tab is with, in this case, this is a Wuko bender. Melco also makes this product. This will turn this panel up, this edge up to 90 degrees, simply with the use of these die rollers. On this tool, there's a measuring stick. I'm going to set this at 1 inch, tighten it, and then I'm tightened down to 1 inch. I'll simply place the roller over top the edge of the panel, keep it tight to the panel, and what I want to do is just allow the rollers, the dies, to do the work. What I don't want to do is force it up by hand. Just simply back and forth. That'll turn it up to 90. And if necessary, just tweak it with your hand folds after the fact. Once I've turned my 1-inch tab up on my rake edge, I'll then measure around this penetration and cut the panel tight around the penetration. Hook down at the end, 10 inches, up to the top of the penetration, 20 inches, and from the side, 7½ inches. And I'll have a raw cut in the front of the penetration, raw cut in the back of the penetration, and I'll turn a 1-inch tab up the side of the penetration, which is going to be a rake wall flashing. I've now got my finished panel. I've made my cut 10 inches up. I've got a cut 20 inches up, and I've turned a 1-inch tab along the rake wall side of the penetration. You'll notice that I've cut off the male edge here on the high side, and that is to allow a flat pan to sit over the back side of the penetration along the water to run along the sides. I'll hook this panel onto the extended eave, pull it up, make sure that my 1-inch tab is flush with the rake, and I'll place 1 screw on the high side. After the first panel has been installed, I can then take my measurements around the penetration and up into the valley to install the second panel. For instance, this lower measurement, 4 3/8, I'll measure off from the female side, and then I can take my tape, mark 16 at the low side, 16 at the high side, scribe a line, and take my measurements back so that I have tight cut of the panel around this penetration. I've transferred those marks to this panel and made the cuts as shown. You can see that I have a 1-inch tab which will hook onto the offset cleat in the valley, and I also have my 1-inch tab that's going to hook over the eave flashing. For installation purposes, it's important to have the eave tab slightly opened slightly more than the tab that's going to go into your offset cleat in the valley. Now, before I can install this panel, I'm not going to place double bead butyl tape on the top of the valley. Instead, I'm going to put tube sealant in the hem of the panel. I'll take this panel and I'll squeeze sealant into the hem. Once I have the sealant inside, I'll simply turn it over and I'll install the panel. Female edge over top of the male. Knock it all the way up so that you're tight against your offset cleat in the valley. I've installed a screw into the top of the panel to hold it in place. I've also run this panel by the top of the penetration by 6 inches. That's important. You cannot install a single panel around a penetration. It's always a 2-piece process, and you always run your first lower panel up to the top of the penetration and then 6 inches beyond that point. if the penetration is 3 feet more wide and they want to use an image type panel, what is the process? The process installation would be identical. The only difference here is that my penetration is only 10.5 inches. Because of that, I can put a small flat pan behind this. Local building codes dictate to what width you must install a cricket, and certainly at 36 inches you're going to install a cricket. So you install a cricket on the back side, and then it's the same process. You just go up to the top side and add 6 inches, top side 6 inches, and you may have multiple panels in the front of the chimney, which is not a problem at all. So once we get the 2 panels in around the penetration, then I need to work from the bottom up. With all installation of metal, as long as you're working from the ground up, you'll be lapping your metal correctly. So we're going to go to the front of the penetration, and we always need to flash the panels at the top side of the ribs. So in this case, we're going to run a pitch brake along the front side of the rib and up the face of the penetration. This is a new pitch brake flashing. The new pitch brake flashing has a 1-inch tab on the back side that is an open hem. This open hem will allow us to slide onto a Z closure. So what I'm going to do is I'm going to take this piece, pitch brake, put it onto right up tight to the penetration. And what's very important here is that this flashing pitch brake stays at the same plane or greater of this panel. With all flashings, they should always be either at the same plane of the roof or directing water down toward the roof. So in this case, I'll get it in place in the same plane, and I'm going to take my pencil and I'm going to mark the rib and I'm going to mark the corners so that I know where to put my closures. Once I do that, I'll pull this off. And I'll take a piece of Z closure and I'm going to cut it to fit here. It's very important is in your first cut that you're going to leave a 1-inch tab. So I'll go in approximately 1 inch. Cut that tab. Turn that tab right in. Piece is a little long, so I'll trim it down. Once I put it in place, I'll then mark the back side. This line here, along the side of the penetration, that line is going to continue down to that line. So that when I place this closure in, I want that line to follow right down through my closure. And there we go. And now I'll cut that and I'll turn a 1-inch tab on that piece of flashing. So when it's in place, tab up against the rib, tab turning up the roof, right along that line, right in place. Once I do that, then I'm going to make a channel that is going to complete this connection. So I want to have metal that continues down and closes off this area here. Now simply putting a Z closure in this area would cause an issue because I'd have this 1-inch tab hanging over. So instead, what I'm going to do is I'll just take a piece of Z closure, cut it down so that it's slightly longer than I need it to be, and I'm going to turn this Z closure into a C channel. Take my hand folds, and I'm just going to flatten it right out. As I mentioned before, To make your bend more precise, go ahead and put a little notch on each side of the metal. And I'll just finish it right around with the hand folds. So that as I'm finished, I've just got a channel, looks like a C, called the C channel. This piece of metal I want to slide right back up in here. So I'll cut a tab on this also. Slide right up in there. And then I want my connection to be right once this Z closure is installed. I have my C channel and my Z closure in place. I want this edge to come all the way through. That's going to be my cut. So to make that cut, I'm going to take my pencil and mark the edge of that Z closure onto the C channel. Complete the cut. And once together, two pieces will slide into place, and I've got a complete closure with proper watershed all the way down and around. I'll then put butyl tape on the bottom and top of these closures and install the pitch brake. Notice that I've cut notches out of the top of the C channel before installation. That allows me to get the drill motor into position to drive the screw straight into the roof. I've placed the double bead butyl tape underneath the closures, and now I'm placing it on the top of the closure. And this will seal up this area. Once that's completed, I'm going to have this panel will hook onto these Z closures with the butyl tape over top. I'm now hooked onto the Z closure at the bottom, can't come up, and I'll put two fasteners on the high side into the penetration. Sealed off. Once we have the front, the pitch brake in the front completed, we'll then transfer over to the sides. And on the side, what we're going to have is a rake wall flashing. This is a residential rake wall flashing. Measures 6 inches wide, has an open 1.5 inch pocket. This allows us to turn a tab up along the wall and simply fit the pocket right over our tab. What I'm going to do here along the side is I'll put it in place. I've added the tabs to the front, the 1/2 inch tab on the front side, 1 inch tab on the back side, and in the open pocket, I'm going to place tube sealant inside the pocket. Once I have the tube sealant inside the pocket, I'll then simply slide this in place over top of the tab. It's important that all your tabs are in the right order. Secure this flashing with 2 screws on the high side. Now what this allows, because I'm only securing this flashing onto the penetration itself, the panel still has some movement. From the back side of the penetration, you'll see that we have panels 6 inches above the top of the penetration. I have 1 inch tabs on the rake wall flashings coming around the top. And at this point, if this was a large penetration, I would build a cricket and install a cricket. With this particular penetration, at the bottom here, I've got 10.5 inches. So that's small enough that I can fit a flat pan behind it. So when making a flat pan, I'm going to measure from the first rib next to the penetration on each side. So I'm coming from this edge and measuring to this panel rib. The measurement is 28 inches. So the width of my flat pan will be 28 inches, and I'm going to bring it up 12 inches to allow connection of panels above it. At that point, I will cut and fold the back side of the flat pan to go around the top side of the penetration. I've made the flat pan. As you can see, I've got tabs, half-inch tabs on the back side to go over the rake wall. I've got a 1-inch tab on the top of the penetration, and I've cut it 28 inches wide. Now this is going to fit right in place just like this. However, before I put this down, I'm going to put tube sealant underneath. Easiest way to do this is just to simply draw a line on each side to determine where to put the sealant. I've now got my lines to show where the bottom of the flat pan will be installed. I'm then just going to take tube sealant and I'll install it up the rib and then back and forth all the way across the metal, and then I'll put a good amount of tube sealant right on the corners, as these are your 2 weak points that you have to be concerned about. Put the tube sealant in all the way across, and then we'll install the flat pan. I have the flat pan in place. I'll secure it with a couple of screws. And then we'll determine where we're going to attach our offset cleat. We want to come across the same cut that we have on the bottom of our flat pan. We want to continue all the way to the rib and place a mark on the rib on both sides, both the female and the male. From that point, we're going to choose points up above the penetration, and we're going to connect the points to put offset cleat all the way around the penetration. When installing the offset cleat, I'll first take my square blade and I'll place it parallel to the penetration. I'll transfer that line all the way up near the top side where I'll be attaching the offset cleat, and that'll be my connector point. I'll then determine what dimension I want for my height for my offset cleat, and in this case I'm going to use 8.5 inches as my top side measurement. Mark, mark, and then I'll just simply connect my marks down at the bottom to the marks at the top. I'll draw a line. And then I can install 3 pieces of offset cleat over double bead butyl tape. I've installed all 3 offset cleats in double bead butyl tape. Once I have those in place, I can then cut my upper panels. What's important is that my second upper panel ends in line with the male rib down below. So this is the male rib. What I'll come back to is 16 inches. Measure 16, and then just make sure I'm close. And I'm right at 12 1/4, which is the width of my bottom panel. So I'm going to cut this panel 12 1/4, turn up the edge just as I've done with the lower panel, cut my miter on my offset cleats for the top panel number 1 and number 2, and then I'll install them. I've cut my first panel, turned up the edge on the rake. I've got 1-inch tabs on the bottom. I filled them with tube sealant, and I'll just simply slide this panel into place, hooking onto the offset cleat. Before I install the second panel, I have to notch out the male leg on the lower panel. Coming right across the back side of the penetration to the point where the offset cleat meets the panel rib, I'm going to notch the male leg down to that point. Now I don't want to notch I don't want to notch the inside of the panel. If I notch the inside of the panel, I have a chance of a leak as water could enter that cut. Instead, I'll notch the outside nailer strip off all the way down to that point. I've cut and folded hems on the second panel. I have tube sealant inside the hem. I'll now install over the offset cleat. Put the panel in place and secure with screws. I've got my rake cleat on, my panel turned up 1 inch. Now I'm going to make a flat cleat, which is going to install over the rake or over the panel edge. So I'll just take a small piece of metal. I'll bend approximately 1 inch, can be smaller, and just pinch it tight. Take my snips. In this case, I need 2 clip cleats, so I'll just cut it straight down the middle. Now for the installation of these, close tight, I'll just twist it, open one end up, slide it right over top of the panel edge. I'll trim this cleat above the drip edge and install a screw. That's going to hold this panel down. Whether or not the rake flashing is ever installed, this is preventing this panel from blowing off the roof. Now I'm going to space these in the same spacing that I'll have my fasteners for the panel. So 18-inch maximum. So I'm going to install one more clip right here at the top. Now the panel edge is secure. This is a residential rake flashing. This is a slip over flashing. There's a 1-inch open hem at the top, which will connect over top of the 1-inch tab on the panel. On the bottom, it has an open hem on the drip edge, and that will slide over the drip edge of the rake cleat. So that when it's installed, you'll simply place it over top, hook right over top of the drip edge, and then to secure it, we'll take hand folds and just close the hem. I've already cut the lower piece and I'm going to install it now. Again, I've got a 45-degree miter here to match up with the drip edge of the Eave flashing. Install the flashing, hook over the cleat, and slide it into place. I'm going to secure the flashings together, the Eave flashing and the rake flashing, with a pop rivet. On the high side of the rake flashing, I'm going to pull it up as high as I can get it, and then I'll also put another rivet through the rake flashings tab into the rake cleat. Once the lower piece is secured, you'll install pieces up the roof. Simply get it into place, pop it over the drip edge, slide it into place. And at this point I can go back and close these hems. It's secured. Now that I have the left to right panels installed into the valley, I'll transfer over to this section. First of all, what I need to do is find the point that this panel rib crosses into the valley. So I'll take my square blade, follow it down, place a mark. What I want to have happen are the panel ribs to line up. So I have my mark here, and at that point, I can measure out 16 inches, as I've got a 16-inch panel, place a mark, and transfer a line down to the eave. Once I have my mark on my eave, I'll measure the panel width, which is 16 inches, place the mark, and at the hip, measure 8 inches to the hip, 8.5. So across the hip the other side, measure 8.5, and then go back to the full width panel. 16 and 16. That's going to leave me a 2.5-inch panel. So that's what I'm going to make. What I don't want to start with a full width panel, because as I move around, I'll get into the valley and my valley panels won't line up. It's always important to try to line up valley and hip panels whenever possible. And that can always be done if the roofs are on the same pitch. If I'm dealing with two roof areas that are not the same pitch, the panels will not line up. However, if I'm dealing with, in this case, a 412 and a 412, I can definitely line those panels up, so that's what I'm going to do. Line up the valley, transfer to the hip, line up the hip, and then I'll deal with the panel width that I have at the rake wall. I've cut my panel for the rake edge. I've turned up my 1 inch for the rake wall. Now I'll install this first panel. Place it flush to the eave, right up against the wall. Once I get it in place, I'll put one screw in the top to hold the panel. And now I can complete the process securing the panel to the substrate with screws. I always want to put my first screw at the lowest possible point. If I go into this slot, I'll be through the drip edge. So I'll come up to the next slot, place a screw in the center of the slot. Once I have the first panel installed, the next step before attaching the second panel is to have tube sealant to the male edge. I'll apply tube sealant on the top of the rib, male rib, from a point at the eave to a point 6 inches up. I'll also apply 2 strips of tube sealant up the side of the male rib on each side of the double bead butyl tape. Again, this is to prevent ice dams and any water that can penetrate the end of the panel from stopping at that point. So we've got the double bead butyl tape and the tube sealant in line. I've installed the panels on this side from right to left. As I come to the hip, I turn a 1 inch tab up directly on the hip. Coming over to this side, again, I'm going to keep the same measurement that I had on the other side of the hip so that I can continue to line up my panel ribs. So I'll measure out 8 3/4, 8 3/4, and then I can just simply measure up 9 1/2. So I'll cut a triangle 9 1/2 by 8 3/4, turn up 1 inch, and then I can install the panel. Panel's cut, tab turned up, ready to be installed. Again, my ribs will line up as I go right up the hip. And I'll continue this process through, up the hip and across the valley till I finish off at the top of the valley. When securing a panel, once it's installed, fabricated up on the eave, I'm going to put a screw on the top edge of the panel to hold it in place. The best place to put the screw is on the female side where you just locked it over, right up as high as you can. The screw is going to be hidden by the Z closures on the hip. So every panel as I put it in, I'll install one screw over right next to the female rib, and that'll hold the panel in place. This is our residential hip flashing. This measures 5 inches on each side. Also have a residential hip ridge that measures 7 inches. Whenever possible, the smaller cap is the best one to use. Typically on a hip, you'd use the 5, and on the ridge, you'd use the 7. What this has 1 inch open hems on each side of the flashing, and that allows us to slide the flashing over top of Z closures, eliminating the need for exposed fasteners. So what I will do, I'll first lay this flashing directly up the hip, and I'll mark the edge of the flashing with a pencil. Just slide it up and continue marking. Once I have the marks, I'm going to install Z closures in these areas. I've got the hip marked out for the Z closures. What's important now to remember is that you need 1 inch tabs on the low end and the high end of the Z closure. Once you have them cut in place to the lines that you've previously drawn on the panel ribs, take butyl tape and install it on the tab and along the bottom side of the Z closure. Peel the backing. And then just simply install the Z closure to the line. It's important that you don't go over the line, as that'll change the way the hip cap fits. You want to stay, a good rule is 1/8 inch behind the lines. Then we'll secure with 1, 2, 3, 4, 5 screws. Typical spacing on a closure for screws is 4 inches. To form the end cap, we need to make a special closure. I'm going to measure down from the top of the Z closure, not just down to the bottom of the Z, which is 1 inch, but down to the bottom of the panel hem, because I want to close this whole corner in. So from the top of the Z down to the bottom of the panel hem, that measures 1 1/4 inches. So I'm going to make a special Z closure, 1 1/4 inches, that's going to go all the way around each side. I now have my 1 1/4 inch high Z closure, and this is going to be used to form my end cap. I cut this Z closure here at a 90-degree angle, so I'll simply use the same 90-degree angle on my Z closure here. This little notch that I cut in here is for this space from the top of the 1 inch Z to the bottom of the panel hem. Simply place my tab up inside so that I have proper watershed, and then I measure out to the corner and add a tab. This is important. I cannot make this angle, 90-degree angle. If I did have a 90-degree angle on this piece, it would twist up in the air. It's very important that the plane of the cap is taken into consideration. So I can take my square blade, put it right on top of the rib, and wherever that hits the Z closure, I can mark. And by simply putting a 90-degree mark here and measuring between these two, I can tell what my miter is. In this case, I've got a 1/2 inch miter. If I have a 1/2 inch miter on this side, I'll have a 1/2 inch miter on the other side. So I've cut this to fit. I've got a tab going up the roof. I've got a tab which is going to help secure the other closure, and I'll simply attach this to the Z closure with rivets. Now when doing this other side, again, this is a 90-degree angle. I'll have a tab coming up the roof, and from this point, I can just measure here from this corner to the very point, 4 3/4 inches, and just add that same 1/2 inch miter. So it'll be 4 1/4 inches on the low side, 4 3/4 on the top side. I'll cut it with a raw edge, and again, attach it with pop rivets. Double check my miter to make sure it looks good. It does fit. So once again, I'll install pop rivets in the corner. Once I've completed that closure, I can now work on my first piece of hip cap. I'm ready to install the hip cap. I notch out the back of each open hem, angle it in. I've got a 3-inch notch here. I'll slide the cap over top of the flanges on the Z-closures. Connect every one as it slides up the roof. Once I get it to the area that I want it to be in, I'll take my pencil and go to the underside of the cap, and I'll mark the edge of the Z-closure. Pull the cap off, and here I have my line. I'd add 1 inch onto here for the hem, which you can see that I've done at the end. This open hem will attach to the end cap. No sealant is needed on top of these Z-closures. You're simply sliding the piece into place. Once I have the hip cap in place, it's very important that I put fasteners at the top so that this cap cannot slide down the roof. I'll line the hip cap up with the hip and put 2 rivets in the cap, 1 on each side, through the flashing and into the closure. I'll do the same thing no matter what the length of the hip is. 100 feet, I'm going to have notches at the high side and a rivet on each side. This will keep this from being distorted or coming off the roof at all. And again, what this does, by closing this up, we do 2 things. Number one, we've got a complete closure here. Nothing can get up inside of this roof system. Also, we have no exposed fasteners dimpling our hip cap. Once I have the lower cap in place, I'll start with my upper cap, and I'll put a telescope notch on each side. The reason for the telescope notch is I don't want to hit these rivets as I slide the cap over, and that rivet will end up in that space that's been notched out. I'll start from the high side and slide the flashing over the Z-closures. Once I get it slightly onto the cap, I'll take tube sealant and I'll put 2 rows of tube sealant all the way down right over top of the rivets. Once that's done, I'll slide the cap into place, and that's the finished product. If I have something up here, whether it be a wall or a chimney, something that's going to prevent me from sliding that last piece on, how will I handle that situation? I'll still start at the bottom, I'll still run them up top. Once I get to that last piece, I'll then come back and I'll make cuts into this piece of Z-closure. I'll take my top piece and I'll bend these tabs wide open for about 3 inches here, and I'll have a slice here. I'll have this sliced so that I can slide it right up. And once I get into place, then I'll just close these back over top. This is a residential peak flashing. This flashing has a 1-inch open hem underneath. We always want to vent a roof whenever possible. This flashing allows us to do two things. If this is a non-vented roof, we can put Z-closures at the top and we can hook on over top just as we did on the hip. Also, if we do have vent and we're going to run a Versa vent, and that's what I'm going to install here, what happens with this 1-inch open hem is anytime, once it's in place, if water ever happens to roll down the face of this peak flashing and start to roll back, you're going to stop right here. If this hem was closed, water will always try to hold on, and it can go back as far as gravity will allow it to. So this has benefits with that open hem. This flashing, it's important that this flashing is placed on the same plane as the roof. Also, this flashing is specifically made to fit the image panel. We also have a residential peak that fits the vertical seam panel. The only difference is the height of the back edge. This top edge is 7 inches, and this gives us a lot of coverage on the top side. What I want to show you is the venting of this system. This is a Versa vent, comes in a roll, has an adhesive on one side. I'm just going to check my measurement before I make my cut. Now simply pull off the backer and apply this right to the metal. It's important that you do not go over top of that 1-inch hem. You want to go right directly behind it. On this end, you'll see I turned a 1/2-inch tab. Again, tabs whenever you can, and that's going to be a way that you can attach this to this rake flashing. 2 rivets at the top. Once I have my peak flashings cut in with proper miters and tabs underneath, I'll then go ahead and attach them. What I'm going to use is a stitch screw, hex head washered stitch screw, and I'm going to attach the flashing down into the panel rib through the Versa vent. And I just want to snug these up so that I do not dimple the face. Once I have the peak flashing installed, I'll connect the peak flashing to the rake flashing with a rivet through a 1/2-inch tab. We'll install a rake wall along this rake wall in the same manner that we did on the chimney penetration. What I'll do here is make this cut and bring the rake wall flashing right over top of my peak flashing. We'll do this just, if you can imagine a hip or a ridge cap flashing here, we want to bring the metal up and over so that any kind of siding everything is lapped properly. So I will take my open hem, fill it with tube sealant, and then again, just slide right over top. Once it's in place, I'll secure it with 2 screws on the high side. And then we can go up inside it from there. This concludes our installation video. For more information about Image 2 panel or other residential panels, visit our website at metalsales.us.com.